My name is Leonardo Kaestner, and this is the video project for Math 242. I will be talking about integration by parts today. Integration by parts is one of your simple tools to use in calculus when dealing with very complex integrals. You usually use this when you have two integrals multiplying each other. And similar to the product rule, when you're dealing with derivatives multiplying each other, you can't just simply multiply them and then take the integral of it. It doesn't work like that. Integration by parts break it up. This mainly takes a large, more complicated integral, breaks it down a bit. And like everything else in calculus, it has a formula. The formula is u dv The formula is the first term with the derivative of the second term in the integral equal to the first term times the second term minus the integral of the second term with the derivative of the first term. It's a little complicated, but I'll break it down. Let's start with an example. The first example I would like to use would be the integral of 4x sine x of dx. Just put this into the formula. When you put this into the formula, you have to determine which becomes u and which becomes dv. Again, I'll explain. When you take this formula, you get u dv So you can have 4 become your u and sine of, you can have sine of x become your dv. Why? Because when you take the idea behind the u and the v is that when you take u, the derivative of u, you get something simple. When you take the integral of v, you get something simple. When you're dealing with this type of problem, you have to look which becomes more simpler if you take the integral of it, and which becomes simpler when you take the derivative of it. In this, for example, I'm going to take the derivative of this one because the derivative of 4x is 4, and that's a simple number you can use. You can take it as a constant, put it outside the integral. If you were to take the integral of sine x, you'll get negative cosine x, and you're not really making it simple. As a matter of fact, you're adding a negative sign into it. So let's not do that. So let's take the derivative of 4x. Like I said, it's 4. While the sine of x is our dv, and the integral of sine of x is negative cosine of x. So you notice the trend. U and v, these are your primary terms. If you take the integral of one number, you get a simple number. If you take, the derivative of the first number, you get the second number. You start, dv is the second given in the formula. You take the integral of this and you get v. The two givens are the first term and the derivative of the second term. So you're taking one term, you're taking the derivative of it, you're taking the other one, you're taking the integral of it. That's the mindset with this formula. So you really have to know your integrals, your givens, as in your trig functions and stuff. So let's actually put this into the formula. You get, compared to this one, you get 4x times negative cosine of x minus the integral of v, negative cosine of x, with du, which is 4. Now, this, for example, had a 4x. This is the only special occasion where you have an integral, you can actually multiply the terms inside. But in this case, we don't really need that. All we can do is just take out the 4 and negative and put it into the constant. So now we just take this as a simple integral by itself. So let's forget the rest of this. You're just dealing with the following statement. The integral of cosine is sine. So at the end you get negative sine of x. You plug this in. You get 4x times negative cosine of x minus 4 sine of x. You can just put these together, you get plus. This is your solution, but you can just simplify simplify this out, for example, we could take out the 4's. So all you're really going to get is x times negative cosine plus sine of x. And that is the answer to the first question. Okay, so I just did the first example. The first example is just taking the integral of 4x sine of x dx. Now, when you're dealing with integration by parts, you're often practicing this with e of x. The reason why is because when you take the derivative or the integral of e of x, you'll get e of x. And as I mentioned before, you should be the number should be getting more simpler when you're taking the integral or the derivative of it. That's how this formula works. So as you can tell, it really challenges the idea behind this. Let me show you this example. 3x squared e to the x d of x. Now, as I mentioned before, doing something with e of x won't get you anywhere. So you should think about more what you should do with this 3x squared. If you take the integral of 3x squared, you get x to the cube. But x to the cube is a little too complicated. It has a third power, and it's very hard to make it simple from there. If you take the derivative of 3x squared, you would get 6x, and 6x is something more you can work with. If putting this as u, the derivative, as I said, was 6x. V and dv are both going to be e of x. So putting this into the formula, you get 3x squared times e to the x minus the integral of ex times 6x. Now you have a separate integral by itself, but it's more simple than this 3x squared. If you look at it, you should kind of stay more constant with what you're doing. If you have 3 of x as a derivative, keep making this first term in your other integrals as well. Keep it as u, because if you change this from u to v, all you're gonna get is 3x squared. You'll be back where you began. So keep this as u. 6x as u, and the derivative of 6x is just 6. While v and dv are both just going to be e of x. So taking this problem by itself, you would get this would equal to 6x times e of x minus the integral of e of x times 6. Here, you can just simply take this out as a constant. And all you're really going to get is 6e to the x. Take this back to this formula over here, and you're going to get 3x squared times e to the x minus, you're not putting this, you're putting this instead. Six x times e to the x minus 6ex. So this is your solution right here, but you can simplify. You can take, for example, 3ex of everything. You get something like x squared minus 6x minus 2x minus 2. And that will be your solution for this problem. Okay, so we have looked at two examples earlier. First one being 4x sine of x, and the other one involving e term, e of x here. Let's look at a third example, one involving both e of x and another term which doesn't really simplify when you take the derivative or the integral of it. In this case, we'll use a trigonometric term, which is either sine or cosine. And So if you take the derivative and the integral of sine or cosine, you don't really get anything simple. You just get the opposite, and that's not really making any progress. But let's look into it anyway. Let's say for example, let's take the integral of ex cosine of x d of x. And you set cosine of x as your u and du as a negative sine of x. And v and dv will both be e to the x. So you continue with the formula, you get cosine of x times e to the x minus the integral of ex times sine of x dx. So you're stuck with another integral problem, but similar with this problem, you just put this into the integration by part formula. So you take this and you get take this separately. You factor out the negative. So at the end you're gonna get negative 1. Let's erase this right here. So ignoring this negative 1, you just deal with this. You get e to the x times sine of x d of x, with sine of x being u and du being cosine of x, with v and dv both being e of x. Okay, so put in the formula, you get sine of x times e to the x minus the integral of ex times cosine of x. Now just pause for a moment and look at what we have so far. If you notice, what we have at the very end, at the very last thing we have is similar to what we have in the beginning. So all we're really doing is going in a loop. This is what I mean by having two terms that doesn't really change when you take the integral or the derivative of it. You will just eventually get the same thing over and over and over. So you have to do a different thing. You have to kind of break the loop and stop plugging it into the formula. So you take what you have and you write it out. From the very beginning, you will write out the integral of ex cosine d of x is equal to cosine of x times e to the x minus negative 1, which we get this, which is a sine x times e to the x minus the integral of ex times cosine to the x d of x. This is what you have so far. So let's get rid of these parentheses. So this just becomes adding. And you can just kind of break this down a bit more. You know that you have an integral on both sides, and they're the same. You just add this to that. So you're going to get 2 the integral of ex cosine of x dx is equal to cosine of x times e to the x plus sine of x times e to the x. So now that you have integral on one side, you can just simplify it. You will get e to the x times cosine of x plus sine to the x equal 2 ex cosine dx. But let's get rid of this 2. Divide both sides by 2, and this is your answer. Again, you really have to analyze what you have and the formula. If you see that you have one term that doesn't change, for example, e, make sure it stays consistent with the letter variable you assign to it. In both these problems, e remains as v. And regardless of how many times I do it, it remains as v. Or else you'll be going back and forth. So yeah, just really analyze this and really work with e of x, especially with these loop statements. These ones get really confusing, and keep an eye on your negative or positive signs. So that's it.